Hello everyone, back to C Code. So, when last we left off, we did our very first Hello World program, and it looks something like this. Now, Hello World, in case you don't know, because I wouldn't expect many people to necessarily know, Hello World programs are sort of a tradition amongst computer scientists and programmers. Every time you make a brand new language, the first thing you write is a Hello World. You write a Hello World just to have the absolute minimum language, the minimum program you can write, and to test to make sure that it works. So we get very into the habit of writing Hello World programs. If I learn Python, I write a Hello World. If I learn C, I write Hello World. If I learn Java, I write Hello World. It is that first program just to kick the tires to try it out. I strongly recommend trying a Hello World on your own. You'll also see that's a regular butt of many jokes in the computer science and programming worlds about Goodbye World or whatever the case is. Hello World programs are just a minimal program to test to make sure that you can compile things and things work. Making sure that Visual Studio set up the project correctly, for example, also extremely useful. So it's just a good idea to try out a Hello World program. But beyond that, we'll get to this here. So what we were doing last time was we were looking at just a very, very quick, well, maybe not so quick, depending on your viewpoint, overview of C. Let's go over some of the individual elements that we're going to be dealing with. Well, first of all, we have some things like keywords. These are language specific that you cannot, that it means something very particular. So if I use the word if, it means something. I cannot have variables named if. I cannot put if willy-nilly somewhere. If is a keyword for doing a conditional. If I use the word float, it means floating point number. It is a kind of data that we're going to be using. Integer, same thing, kind of data we're going to use. Operators would be something like a keyword. It means something in particular. So if I have a plus, it's not exactly a keyword, but if I have the plus operator here, it means I'm going to add two things together. Punctuators. I don't know. I would say comments more than anything for this instead of punctuators. But curly braces are things that help you parse the program. Semicolons used for essentially for punctuation for the program. When I write an English sentence and I want to end my sentence, I put a period. In C, I don't put a period because it's not an English sentence. I put a semicolon. That's the end of that instruction. If I want to finish off a paragraph, I will put a blank line between. I'll press enter again and put a blank line in between my first and second paragraph, or any two paragraphs. That's the same as our curly braces, where it says this is the end of this function, or this is the end of this if statement. Curly braces tell you the end of things. Same with semicolons. So these are kinds of effectively punctuation, allowing the compiler to figure out what you're trying to get across. We have particular identifiers, or a particular function name, or variable name. These are how you identify that particular thing. That variable, what's its name? It's named foo. Well, foo is the identifier for that variable. The variable is the storage of data somewhere, right? It's some number being stored somewhere. How do I identify that, where that is? Foo. It's a name, right? My name is David. That's my identifier to identify me as a human. But David is not who I am, it's just the name to identify me. We have constants. Things like text is a constant. You cannot change text when in the middle of, like if I have a piece of text, I cannot just modify it and change it. Also, numeric constants. I can put constant values in there that are not going to change. They also have an identifier, but they're a constant value. They're not variable. And then we have comments. Now, I would say that's closer to this, so let's put that up down here. Comments are things that you're just going to, the compiler itself is just going to ignore, it's going to throw it away. It's for humans to read. And they're often colored differently just so you make sure you don't actually mix those up. Variables themselves are one of the foundational things that we have to deal with in a language like C, called an imperative language. So we are storing data in memory somewhere. We need some way of identifying what that is. When I say I want this variable, I have a name for it. And the compiler knows where that variable is stored somewhere in memory. It handles all of that stuff. You just say, give me foo, or give me my var, or whatever you named this thing, and it will get it for you. C uses what's called an explicit type declaration, as in JavaScript doesn't do this. but Python sort of does this. It's a strongly typed languages, and I say I'm going to have, and it's explicitly typed. It's both strongly typed and explicitly typed. I'm saying I want this to be an integer, and it gives me an integer. It's only an integer. It is the particular type of data it is. We'll look at this in a second. It has a name, and you cannot explicitly change the data, how the data is. You can in C you can change how the data is interpreted without changing the data by via something called casting. You can say no, I'm going to pretend it's not an integer, it's a character now, and just pretend it's something that it's not. And that's why we had to look at binary and hex. But under the hood, we're saying it's normally considered an integer and treat it like that. We'll go over this right now, or soon. Here are the different types we have. We have integers. These are whole, negative and positive whole numbers. So not whole numbers. This is, if you know your math, by the way, it is a set of integers, right? These are numbers from negative to infinity to positive infinity, and they're not fractions or anything like that. So -1, 5, -17, they're all integers. 0 is an integer as well. Okay, int is normally what we use for it. So int is normally 32 bits of signed, a 32-bit signed integer, meaning, and this is where we get to the signed and unsigned. A signed integer means that it has a positive or a negative sign. It's very counterintuitive. Unsigned means you have the same darn number. It's still stored the exact same way. It looks identical to a signed integer. Everything, the binary is exactly the same, except we're just saying it's only positive. So if I have when we're talking about 2's complement, I said it can either be 15, right, a 4-bit binary number with 4 ones in a row. A 4-bit binary number could either be considered 15, which would be an unsigned integer, or if I say it's a signed integer, it's now -1. It's interpreted as -1. The binary under the hood, the binary that we're using, is exactly the same. It's negative. It's 4 ones in a row. But if it's unsigned, it's interpreted as 15, and if it's signed, it's interpreted as -1. If I have a 4-bit binary number for the number 4, signed and unsigned are identical to one another. So 1, 2, 3, 4. This is -1, 15. If I have, let's say 4, I said 4, right? 0, 1, 0, 0. This is 4, and oh wait, unsigned and signed, it's exactly the same, right? These are the exact same numbers. I'm gonna have to clean this up actually, right? 4 and -4. Whether I have 4, if it's 0, 1, 0, 0, it's 4 no matter whether it's signed or unsigned. It only makes a difference for negative values. Okay. Let me also get rid of this one right here. Boop, boop. Okay. Because I know this is coming up. A short is just the same as an integer, except it's a bit shorter. Instead of 32 bits, it's 16 bits, a bit smaller. Sometimes if you're really worried about space and you're only dealing with, say, numbers between 0 and 255 or something like that, you can use a short. It's just a smaller number. If you don't need the extra space, if you don't need a giant, so it's like I like the metaphor. I don't know why I love this metaphor. If I'm packing up something, we have this problem with Ziploc bags, right? You have leftovers, or you want to bring something to school. If I have something really really small, I have like a snack size Ziploc bag, so I could put little tiny things like crackers or something like that in there, but I can't put a sandwich. That would be a short, right? A little thing for almonds, for example. It's a little tiny Ziploc bag. An integer can hold a sandwich, right? It's a bigger bag. And then we actually have what's a long. It's actually now called long longs. Yes, honest to God. Oh, sorry. A long is 32 bits. Is exactly the same as an integer. It used to be bigger than an integer. They changed it. A long long is 64 bits. It's even bigger. That's like one of those giant freezer Ziploc bags, right? If you're only putting a couple almonds in a giant Ziploc freezer bag, you're wasting a bag, right? It's way too big of a bag for a couple almonds, right? So if I have only, if I know I have very small amounts, I want to use a short. If I have a normal size amount, like a sandwich, I'm going to use an int. And if I'm going to put something big in there, like I'm putting a whole bunch of ground beef in the freezer, I'm going to use a long. It's going to be big. I need to have all that extra space. You normally choose something that works for you, but the vast majority of time, an integer works, right? An integer is not too much overkill for you to throw a couple almonds in a normal Ziploc bag. Not the end of the world. If you and you're not going to run out of space, right? You're as long as you're not that worried about it, it's good enough. So ints, as a general rule, just go with an int. And by default, if you just say int, it's signed. Unless you explicitly state something is unsigned, it's going to be interpreted as positive or negative. Okay, int is the go-to variable type. Great. So here are the value ranges that we can do. For a signed short, for example, I can go from negative 32,000 to 32,000. Okay, it's actually might be a bit more than that. I think there should be an 8 in here, but it doesn't really matter. It's about that amount. Unsigned goes 0 to 65,000, right? That's not that many numbers, really, when you think about it, when you're talking large numbers. A signed integer, though, goes from negative 2 billion. Yep, billion. 2 billion to positive 2 billion, or from 0 to 4 billion, right? A fairly big swath of numbers. And if you go to 64-bit, I'm not even sure what the heck that is. That's the billions, that's the trillions, that's whatever. Yeah, gigabillion. No, it gets much larger numbers that you can represent, right? If you need something that big, go for it. But most people don't need a number that big for most things. If you're talking if you have a multi-terabyte hard drive that you're dealing with, yeah, sure. If you want the address of something, you'll want to use a 64-bit number. These are big numbers that you're dealing with, but it's most of the time it's overkill if you use a long. Integer is your friend. Okay, here are floating point numbers that we talked about before. Floats and doubles. Their float is 32 bits. A double is 64 bits. They are normally quote unquote real numbers, right? This is that float how we had nonlinear numbers that we talked about earlier, where I'll have the way it's represented is I show the exponent. I keep one of the part of the number is to represent the exponent. There's a sign bit, and there's part of the number is representing the actual mantissa, if I'm pronouncing that right. Mantissa. A double's twice that length, so it can store way of much larger or much smaller numbers. Characters are the odd duck out of this whole thing because they sound like the most precise thing. They sound like the thing that's going to change the most, and yet they have changed the absolute least. The word character is perhaps a misnomer, and that's where I get a little weirded out by characters. This is exactly. They are consistently 1 byte in length. They have been 1 byte in length since the 1980s, if not earlier. A character, actually earlier, a character is normally 1 byte. It is normally considered an unsigned character, but you can have signed and unsigned characters. But it is normally 8 bits. What's special about characters is that we're going to talk about them in a lot more detail, but they're normally letters of the alphabet. More specifically, just to address the elephant in the room, it is specifically predominantly English centric letters. If you want to write Mandarin, tough luck. You can't do it with a char. If you want to write Greek, you may have some trouble. A lot of it does not support many languages. Thai is completely out the door, right? There's a lot of languages that are completely unsupported by characters. We'll talk about that when we talk about characters, but it's because they were never designed for other languages. They were designed for the English language to prevent, honest to God, prevent World War III. That is actually the origin of characters. They're using something called ASCII, and we'll talk about that in more detail later on. But they're not meant to be representing anything other than normally English letters. the weird quirk about characters is it's the only thing we can guarantee in terms of size, or one of the only times we can actually guarantee things in terms of size. Floating point numbers could tomorrow the Visual C++ could turn around, or C could turn around and make a float 64 bits, and all your code should still work. They can make integers 64 bits, and all your code should still work. Characters are one of the few cases where we are saying, yeah, it better be 1 byte and only 1 byte. Don't try and change it. There's one the few times where we're it's consistent and has not changed over the years for C. Everything else has. Integers have increased in size, but chars have not. And the weird one is booleans, which some of this is from other instructors, and then I had to add a lot of extra comments in there. Booleans in C are true or false statements, fine. They are actually represented as 0 and 1, but they still take up a full byte of memory, like a char. What's even weirder about this, it is not actually pure C. That is actually, booleans do not exist in C at all. They are C++. They are only for C++, but we'll ignore that little factoid. And what's really even more strange about this is that booleans not only do not exist in C, but they don't work the way you would expect. They are not just true and false. They are 0, which is false, and not 0, which is true. Anything that is not 0 is true, and we will talk about that later when we talk about if conditionals and the like, because it leads to all sorts of weird, wacky things we can do. You either have it 0 or you have it as not 0, and that's it. That's all you get with a boolean. That's what you test for when you're testing it with we have a if statement saying if this is true, then do this. We will test if this thing is equal to 0. Otherwise, if it's not 0, it's true, and it leads to some fun. Okay, so these are the different types of variables that we have. So here's a little short form, right? We have ints, we have unsigned ints. This is mostly what all you're going to ever do, right? We have shorts, we have floats, we have doubles, we have chars, we have bools. We have technically longs, but I have never written a long in my life, I don't think. Or if I have, it's been years. It doesn't come up that often, especially for, course code, right? Most of the other things might come up from time to time. These are the types of variables that we can store. These are the buckets and how they're interpreted. They're still storing a certain amount of data. So an integer, let's say an integer is 32 bits, it has 32 ones or zeros in a row. It's a chunk of 32 different bits. And how it's interpreted depends on what you're doing with it. So it has a certain amount of storage and how it's interpreted. And those are two different things. They each have a certain amount of storage, and a char will be treated differently than a double versus treated differently than an unsigned int. And wait, there's more. We're not going to get into this detail quite yet, but just in case you're wondering if other things are coming up, yeah, we're going to have pointers, we're going to have arrays, we're going to have constants, we're going to have static variables, which we're not even going to talk about for this course. We're going to get that in 2400. And we have structs, which we're going to get to later on. There's a lot of other stuff we can do in C than just these basic types. But those are the foundational basic data types. These things right here. You say, I want a variable of that type, and you get that amount of storage. Period. Nothing else. Okay. So here's how we can declare a variable. So we declare what type of variable it is. So give me 32 bits of space for this integer. Give me 32 bits of space for this float, for example. We give it a name so we know where the heck it's being stored. When you say give me 32 bits of memory, and tell me where it goes so I can get to it later, right? I want a safety deposit box. You also need to tell me what the number on the safety deposit box is. Otherwise, you just get a full safety deposit box and you can't even use it, right? So I need to know what the name of it is so I can find it again or refer to it again. I need to get the actual memory from the system. The system will give me a chunk of memory to put stuff in. So that is then the type of data. There's the suitable name is number 2, like float A. float is a type of data, A is the suitable name. And then at the end of all this, after that, when I'm done with that line, I put a semicolon at the end saying, and I'm done. That's all I'm doing on this line. We can go a bit further. We could say, I want a double named B, and I'm going to set the value for that double to be 1.2 to start. What is that as a binary number? I don't know. I don't care. I don't want to know. That's why I don't like some of these things like doubles. Here is, I'm making an unsigned short integer. That is a 16-bit integer, and it's unsigned, so it can't have negative values. The name of that variable is C. These are terrible variable names, by the way, and it's going to have a starting value of 2. Here's an unsigned, here's a signed long 32 integer. So that's 32 bits. It's signed, so it can be positive or negative, and it's going to be given the value of C, whatever C was. Oh, wait, C was the value 2. The value 2 is here. It doesn't get the letter C. It doesn't get something else. It is whatever was in C, I'm going to put in here. So here's my declaration. Here, so the type, here's the variable name. And if I go back over this again, I have, that's one type. Here's a variable name C. Here is what's in it. It's initialized to. And my variable can be initialized to another variable. It is going to see whatever is in the bucket for C, figure out what that value is. It's the value of it is 2, and it's going to put that in D. And if you don't believe me, if we want to debate any of this stuff, we can just write the code and see it in action. That's one of the nice things about computer science and programming. So here we go. A, what is it initialized to? I don't know. We didn't start it off at anything. That leads to problems. B starts off at as value 1.2. Whatever in those 64 bits of data stores 1.2 as the value. In the 16 bits of data that is C, it stores the value 2. And in the 32 bits of data, it stores the value 2, not C, 2. It takes whatever this was and plops it into D. Notice A was not initialized. So that leads to all sorts of wackiness. If I don't initialize it and I try and use it, I got garbage in there. I have no idea what was put in there. It doesn't get necessarily set to anything to start. Java does, some other languages do, but C in its infinite wisdom said, let's save some time, let's not initialize it to some safe value. You'll get whatever the heck was in there before, have at it. So it is, you're giving me a box, but you didn't empty the box, you just whatever. And it's up to me to dump out stuff and put new things in the box. It's kind of fun that way. All right. Also notice the names of these variables, despite these variables being terrible variable names, I want normally meaningful variable names, and they are case sensitive, meaning whether it's uppercase or lowercase makes a difference. So my var and my var, the capital M makes a difference. Those are completely different variables. And so my big piece of advice to new programmers is pick a lane. Choose a particular way you want to name your variables. We have particular ways. I like this. I start off lowercase. Every time I have a new word or new word in my variable, I'll put an uppercase. It's called camel case. I'll put an uppercase letter. So my var fooey the fooey would be a capital F, right? So I can read it like a series of words stuck together. And I will be consistent. I will always start with a lowercase. I will always use a capital letter there, so that when I type the variable over and over again, I don't accidentally mix up uppercase and lowercase. If I'm consistent, I don't get these weird errors where it says the variable is not declared. Oh wait, you spelled it wrong. Or oh wait, it's uppercase when it actually is meant to be lowercase. Those kinds of bugs are really hard to find if you have some variables uppercase, some variables lowercase. And another little, you shouldn't have thought to do it anyways, but just in case you were tempted to, you cannot name a variable to be one of these keywords. You cannot call it your integer int. Just, you're not allowed. You cannot call your integer char. You cannot call your integer if or for or any of these keywords. Those keywords are sacred. You're not allowed to touch them. And for good reason, because you're just asking for trouble if you name your variable. If you name your variable integer variable int, you're just asking for trouble. Which one do you mean? Okay, so the variables can have a name of the user-defined function, can have the name of a user-defined function. So you can have a name of your function. Let's say your function's name is foo. Your variable could be called foo as well. I don't recommend it. I find it leads to problems. So you can reuse names in some other ways, but try not to. Unique names are good. It leads to other problems. And hopefully you'll make sure your names are useful or meaningful, right? I don't want to call my integer a. Why? Because what's a trying to represent? I don't know. Right? So variables are for our benefit. The CPU doesn't need it. The programming language or the machine code that's generating is not going to be using the variable a name a. The a is nowhere in your actual machine code that you generate. It is some unique identifier where the address is in space. It doesn't actually have a name for it. The name is for you. Just like my cat doesn't care what its name is, the name is for me. So the name of the variable is important for you so that you can find out what it does and you can understand what your code is doing. Coming up with a variable name is an art form. And if you don't do a good job at it, honest to God, people will mock you openly. I have had numerous programmers mock me openly for bad variable names. It's one of those little, I don't know, how you poke fun of each other, you tease each other about that sort of thing. If my thing is summing up numbers, sure, call it sum. That's an okay variable name. But people will actually judge you on your variable name. Much like if you name your kid some horrible name like ABCD or something. I don't. Hopefully, none of you have that name in the class, right? If you have some horrible, if your parents name you some horrible name, you got to go with that horrible name for the rest of the time. That's not so fun. Same with variable names. Think of a good one. Make sure it's a good one. Make sure it's meaningful and you understand it, and it uses the right convention. We do have one consistent thing we're allowed to use A, B, and C for, that sort of thing, and we'll get to it later. But I, J, X, Y, and Z, or Z, if for the proper Canadian way of pronouncing that, X, Y, and Z mean something. X, Y, and Z, they're coordinates in space. So I can have a variable named X, and everyone goes, "Ah, that's a coordinate in space. That's the X coordinate." Right? In three-dimensional space, it's the X coordinate. I and J, by convention, I stands for index, and it is a counter by convention. Everyone uses I and J. Don't try and fight it. Just go with it. I and J are very, very common to be used there. That's fine to use as variable names. But if you name your variable B for no reason other than you were just being lazy, yeah, we're not going to like it. Okay, so I like leaving things at little cartoons. When we pick this up, I'll have hopefully a little short video on declaring variable names and a couple other things. So descriptive variable names, short variable names, it is what it is. We will spend large amounts of time humming, hawing, and just panicking over the names of our variables and our functions, and you should too. Okay. That being said, let's stop this and go to the next video.